So what's up, guys? In chemistry, we hardly talk about acids without talking about bases. The reason why we call some substances acids and some substances bases are very connected. This is because the most important thing that identifies a substance either as an acid or a base is its behavior in water. Now, there are three sciences that worked to help us understand acids and bases, and you have heard about them in previous lessons. Their names are Svante Arrhenius, Johannes Nicolaus Bronsted, and Thomas Martin Lowry. These three scientists helped define acids and bases and found out a lot about their behaviors. I'm going to give you the definition of acids and bases according to these scientists. But first, let's remind ourselves how we defined acids in the last lesson. Now, when acids are dissolved in water, they dissociate to release a proton or a hydrogen ion from their molecules. On the other hand, when bases are dissolved in water, they release a negatively charged ion known as hydroxide ion. A hydroxide ion is a radical made up of an atom each of hydrogen and oxygen, and it carries a negative charge. Bases can release this hydroxide ion in three different ways. The first way is to release this hydroxide ion from themselves, like sodium hydroxide. A common base, it does that in water. Now, not all bases behave this way. To differentiate it from other bases, let's call these kinds of bases type A bases. Other bases would release this hydroxide ion from the water themselves by taking away the hydrogen ion present in the water molecule. An example is ammonia. Now, there are other compounds that behave this way, so let us call them type B bases. The third type of bases simply dissociates the water to release hydroxide ions. An example of a base that does this is sodium carbonate, and we would call these type C bases. All in all, it seems that all bases release hydroxide ions when in water. And guess what? That is exactly how Arrhenius defined bases. In the year 1884, Svante Arrhenius, a Swedish chemist, defined bases as any substance that produces hydroxide ions when dissolved in water. Arrhenius studied acids as well, and as we learned in the previous lesson, he defined acids as substances that release hydrogen ions when dissolved in water. Now, the interesting thing about this definition is that when you combine a hydrogen ion with a hydroxide ion, you would get water. Now, this means that when we mix a solution of an acid and a base, the hydrogen ions will combine with the hydroxide ions to form water, alongside a salt formed from the remainder of their molecules. This reaction of an acid and a base is called neutralization, and it is important in understanding the behavior of acids and bases. It is such an important reaction that eventually the other two scientists we have talked about, Johannes Nicolaus Bronsted and Thomas Martin Lowry, redefined both acids and bases to fit these reactions. Now, some substances could participate in this neutralization reaction without releasing their hydroxide ions. An example is sodium oxide, and here is the reaction. As you can see, it also produces salt and water. These reactions show that a substance can neutralize an acid without producing the hydroxide ion. The base simply provides a negative ion that can accept the hydrogen ion provided by the acid, as you can see when we expand this reaction. So, Bronsted and Lowry, though they worked separately, agreed that a base should simply be defined as a substance that accepts a hydrogen ion or proton. Hence, according to Bronsted-Lowry, an acid is a substance that donates a proton, while a base is a substance that accepts the proton. Another scientist named G.N. Lewis also gave his own definition of acids and bases, but we will discuss that much later. Meanwhile, you should understand that 1. Arrhenius defined bases as substances that release hydroxide ions in solution. 2. Bronsted and Lowry defined bases as substances that accept protons when they react with acids. And bases all react with acids to produce salt and water. Now that is all we need to know about bases for now. See you in the next lesson.